You think you understand time. You wear a watch. You feel yourself getting older. You remember yesterday and you plan for tomorrow. Time seems obvious. It seems like the most natural thing in the world. But that's not time. That's just a sensation, a biological trick your brain plays on you. Most people walk around with this poetic idea in their heads that time is a river. You imagine it flows, sweeping you along from the past, through the present, and into the future. You think it moves. But here's the problem with that beautiful image. If time is a river, how fast does the river flow? 1 second per second. That's meaningless. That's like saying a table is 1 table long. It tells you absolutely nothing about the nature of reality. The truth is much stranger, much more mechanical, and honestly a lot less romantic than a flowing stream. Time doesn't flow. Time doesn't push you anywhere. And if you think you have a good grip on how time works, just because you can count seconds in your head, you're in for a very rude awakening. Let's start with what goes on inside your brain, because that's where the confusion begins. You think your internal clock is a reliable instrument. It isn't. It's a chaotic mess of translation schemes. Consider a simple experiment. Try to count to 60 seconds in your head. Just sit there and count. 1, 2, 3. You think you're tracking time, but what you're really doing is running a very specific, very personal program. Some of you, when you count, you hear a voice in your head. You're literally speaking to yourself, sub-vocalizing 1, 2, 3. If someone interrupts you and asks you to speak, you lose your count. The machine jams. But others, and this is where it gets interesting, don't hear a voice at all. They see images. They might see a tape measure with numbers on it clicking past like a ticker tape. Click, click, click. If you use that visual tape measure system, you can actually read a newspaper or check a laundry list while you count time. You can sort your socks, look at patterns in the weaving, and still keep that mental tape measure clicking perfectly. But the person who counts with a voice, they can't read a word without losing track of the time. This tells us something fundamental. What you experience as the passage of time is just a mental construct, a pattern-matching game your brain plays. It varies wildly from person to person. It is not a universal constant. It's a biological hallucination. So when we talk about physics, when we talk about the universe, we have to throw your brain out the window. We have to stop talking about how it feels and start talking about what it actually is. In physics, we have to be operational. That means we don't ask, what is the essence of time? Because that's a question for philosophers who enjoy arguing over coffee. We ask, how do we measure it? And the answer is almost disappointingly simple. Time is just a way of ordering events. That's it. It's a labeling system. Imagine you have a deck of cards. You lay them out in a row. You can say the jack is before the queen and the king is after the queen. The cards aren't moving. The table isn't flowing. The order is just a structural property of how the cards are arranged. Time is the table. Events are the cards. When we say time passes, we're just reading the cards from left to right. This brings us to the biggest mistake everyone makes. You think time is a container. You imagine the universe is a big empty box, and time is a clock on the wall of that box ticking away, even if the box is empty. You think that if we removed all the stars, all the planets, all the atoms, and all the light, time would keep ticking. Tick, tick, tick. Wrong. This is the Newtonian view, and it's dead. Time is not a background stage. Time is a measure of change. If absolutely nothing in the universe changes, no atoms vibrate, no light moves, no energy shifts, then time stops. It ceases to have meaning. You cannot define a second without a physical process to mark it. a swinging pendulum, a vibrating quartz crystal, a cesium atom oscillating. Time is not separate from the stuff in the universe. Time is a property of the stuff. This is where your intuition fights back. You say, okay, but surely time acts on things. Time makes me get older. Time causes the milk to spoil. No, it doesn't. This is a linguistic trap. Time is not an agent. Time doesn't have hands. It doesn't reach into the fridge and sour your milk. Bacteria do that. Chemical reactions do that. Entropy does that. Time is just the bookkeeping system we use to track the rate at which those reactions happen. Saying time did it is like saying inches built the house. Inches didn't build anything. Carpenters did. Inches just tell you where the walls are. Time is the ruler, not the worker. Let's push this ruler analogy further because this is where things get really weird. If time is just a ruler we use to measure the distance between events, what happens if the ruler itself is flexible? This isn't science fiction. This is measurable fact. We used to think that a second was a second anywhere in the universe. If you had a clock on Earth and a clock on Mars, they would tick-tock in perfect unison. It feels obvious. It feels right. And it's completely false. The rate at which clocks tick depends on where they are and how fast they're moving. This is not a mechanical failure of the clock. It is a fundamental feature of reality. Imagine you're driving a car across a giant flat sheet of paper. You can drive north or you can drive east. If you drive purely north, you're making maximum progress in the northward direction. But if you turn the steering wheel and start driving northeast, you're sharing your speed. You're moving a bit north and a bit east. You aren't going north as fast as you were before because you diverted some of that motion to the east. Now replace north with time and east with space. This is the essence of relativity. You are always moving through the universe at a constant speed. But that motion is shared between space and time. If you sit perfectly still in your chair, you're dedicating all your motion to moving through time. You're traveling into the future at maximum speed, 1 second per second. But the moment you stand up and walk, or get in a rocket and fly, you're diverting some of that motion into space. You're moving through space, which means you must, mathematically must, move slower through time. Your clock slows down, your aging slows down. You aren't breaking the machine, you're just changing direction on the map. If you could move at the speed of light, which is the maximum speed limit of the universe, you would be using 100% of your motion for space. You would have zero motion left for time. For a photon of light, time does not pass. It is born and absorbed in the same instant from its own perspective. The universe is frozen. Now, you might be thinking, well, I don't feel my watch slowing down when I run for the bus. Of course not. You're too slow. You're a biological snail. The effects are tiny at human speeds, but they're real. We have to program satellites with this math. GPS satellites are moving fast, so their time is different from your time. We literally have to adjust their clocks. If we didn't, your GPS would be off by miles within a day. There's another aspect of time that tricks us, and it comes back to that counting problem, the idea of pattern recognition. We perceive time as having a direction, an arrow. Past is fixed, future is open. You can remember breakfast, but you can't remember dinner. Why? If physics equations work forwards and backwards, and most of them do, why can't we remember the future? If you film a planet orbiting a star and play it backward, it looks perfectly fine. It obeys all the laws of gravity. But if you film an egg falling on the floor and breaking, and then play it backward, Everyone knows it's fake. The yellow yolk doesn't leap off the floor, assemble itself into a ball, and seal itself inside a shell. Here's the secret. This isn't about time itself. It's about probability. It's about disorder. It is much, much easier to break an egg than to build one. There are a billion ways for an egg to be broken. Scattered here, splattered there, shell in 3 pieces, shell in 1,000 pieces. But there is only one specific arrangement where the egg is whole. So as things move and interact, they naturally stumble from the organized state, few options, to the disorganized state, many options. We call this entropy, and this is the only reason you feel an arrow of time. You're watching the universe shuffle the deck of cards. You started with a perfectly ordered deck, and every second that ticks by is just the universe shuffling it a bit more. You can't unshuffle the deck just by hoping. This means that your sensation of time flowing is actually just your brain registering the increase of messiness in the universe. You're a disorder detector. When you distinguish the past from the future, you're really just distinguishing less messy from more messy. If the universe were in a state of maximum mess, maximum entropy, where everything was evenly spread out and nothing interesting was happening, your brain wouldn't be able to tell the past from the future. There would be no egg to break. There would be no memory to form. In a thermal equilibrium universe, the arrow of time vanishes. Ouch. So, let's go back to those people counting in their heads, the ones seeing the tape measure versus the ones hearing the voice. They're both struggling to impose a rigid linear structure on a universe that is actually much more flexible. We build these mental models, these counting machines, because we need to survive. We need to know when the tiger is coming or when the harvest is ready. We evolved to track duration, but we did not evolve to understand the dimension of time. Our brains are efficient, not accurate. We focus on the now because that's where we live. But in physics, now is a very slippery concept. If you and I are standing next to each other, our now is effectively the same. But if you're on a planet 1,000,000 light years away and you start walking away from me, your definition of now slices through the universe at a different angle than mine. What you consider to be happening right now might be in my future. What I consider right now might be in your past. There is no universal now that covers the whole universe like a blanket. The universe is a block of events, a 4-dimensional loaf of bread. And how you slice that loaf depends on how fast you're moving. This is hard to grasp. It feels wrong. It feels like I'm telling you that up is down. But that's because you're trying to translate the high-level language of the universe into the low-level language of your biology. You're trying to count socks when you should be measuring light beams. When you try to force the universe to fit your intuition, you get confusion. You get paradoxes. But when you let go of what you think time is, when you stop trying to count it like a pile of laundry and start measuring it like a dimension of space, suddenly the equations work. Suddenly the universe makes sense. We're not done, because even if we accept that time is a dimension and that it stretches and squashes with speed, there's a much deeper question lurking at the bottom of the well. We talked about measuring time and we talked about the arrow of disorder, but we haven't talked about the beginning. If time is a measure of change, what happens when you run the movie backward all the way to the first frame? If the universe is expanding and we wind it back, it gets smaller and smaller, hotter and hotter. Eventually, you hit a point where the laws of physics themselves start to melt. You see, all our clocks, our atoms, our planets, our light beams, they exist inside the universe. But if the universe itself was born in a moment we call the Big Bang, does it make sense to ask what happened before that? This is the ultimate test of your new definition of time. If time is just a way of ordering events inside the universe, then asking what happened before the universe might be as nonsensical as asking what is north of the North Pole. It sounds like a valid question grammatically, but geometrically it's gibberish. There is no north of the North Pole. There may be no time before time began. And yet we still have that nagging feeling, that internal counter, that voice counting 1, 2, 3. We desperately want the universe to have a backstory. We want a timeline that stretches back forever. It's hard to accept that the tape measure might just start, that the counting machine had an on switch. This creates a friction between our psychology and our cosmology. We are finite beings trying to comprehend the infinite using tools made of meat and electricity. It's a wonder we understand anything at all. Consider the patterns again. The person who sees the tape measure in their head can count while reading because they're using different circuits, visual versus verbal. Physics is the same. Classical mechanics was the verbal counting. It worked for day-to-day stuff. Relativity is the visual tape measure. It allows us to process complex patterns that the old way couldn't handle. We're constantly upgrading our mental software to match the hardware of reality. And the upgrade process is painful. It requires discarding ideas we love, like the river of time. But here's the beautiful part. Even though your intuition is wrong, even though your internal clock is a biological hack, and even though time is a flexible, relative, bendy dimension rather than a strict metronome, it still works for you. You can still boil an egg. You can still meet a friend for coffee at 2 p.m. The weirdness of relativity is hidden under the hood. You don't need to understand the combustion engine to drive the car, and you don't need to understand space-time metrics to live your life. But isn't it better to know? Isn't it better to know that the engine is there? This brings us back to that strange experiment with the counting. Remember the difference between the person who hears numbers and the person who sees them. This is not just a party trick. It reveals a terrifying gap in how we understand the universe. When two people talk to each other about something complex, like time or relativity or love, they think they're speaking the same language. They nod. They agree. They say, I understand. But what's really happening? You're running a massive, invisible translation scheme. You take the words I say and convert them into your private internal imagery, which might be completely different from mine. I say 1 minute, and I see a clock face. You hear a voice saying 60 seconds. We arrive at the same answer, so we think we agree, but the machinery inside is totally alien. This matters for physics because it exposes the fragility of common sense. Common sense is just the collection of prejudices you acquired by age 18. It's built on your specific internal imagery. If your mental image of time is a tape with numbers on it, you'll struggle to understand how time can bend. If your mental image is a voice counting, you'll struggle to understand how time can be spatial. When we try to teach you about the quantum vacuum or the curvature of space-time, we aren't just giving you new facts. We're asking you to delete your operating system. We're asking you to throw away the tape measure and silence the voice. And that's why it feels so hard. That's why your brain rejects it. You aren't just learning. You're translating against the grain of your own biology, own